So, Robert.
Did I understand you to say that one of the choke points is how long you can fly the drone, or was it that you can't gather enough data on the drone and get it back? Is it just a lacking? Doesn't have enough gas to do it? Or is it that you're gathering too much information?
So the drones actually come in all different shapes and sizes. So there are like a very cheaper drone to very more advanced drones. So, and each one of them, if you go inside, like they have different kinds of capabilities. Okay, how much memory, how much compute power is there. So based on that, what we are trying to do is like our solution, what we are trying to make it configurable. So if you have a drone type A, let's say it has enough compute power, enough memory, it can actually carry the model itself. Okay, so then when it is flying, not only it is getting in the image, it is trying to do inferencing and send that result. That is one extreme. But if the drone doesn't have a large amount of memory or compute power, it can just take image, okay, and then send that image to a near edge or to cloud or to HPC based on the solution what the user wants, and the inferencing will take place there. So we are giving a spectrum of solutions based on the drone capability and how much somebody also wants to spend. That is also a cost factor is also there.
Okay, if you have a problem with too much data, I can help.
Okay, good, sure, we'll talk.
Any other offer of help? Oh, there is here. David, right? That's Hello, this is not really in the HPC space, so feel free to tell me off if it's too off topic. I can definitely see the use for this kind of thing where you have large fields and commercial operations where you have uniform crops and that kind of thing. I was wondering, has there been any work done in non-uniform crops, such as companion planting, that kind of thing? And also as a follow-on from that, how do you work to include underserved communities in your co-design processes? I'm curious as to how that kind of thing works at your level.
The second part I didn't get. Can you please repeat?
How do you work with underserved communities as part of the co-design process?
Yes. So the first part, I think, I forgot the first part. Can you please repeat this?
The first part was talking about non-uniform crops where you have multiple different plants in the same field.
Yes. So that means that is a very interesting thing. We have not reached there yet, okay? Because currently we are focusing on the models for a single crop, but as you said, like sometimes the farmers have 2 or 3 crops together. So in our framework, it is not there yet, okay? So that is the next phase. If we have a good understanding of each crop, then we'll try to go to the hybrid crop or cover crop, whatever they say. There are a lot of different terminologies we'll be working. The underrepresented groups and all, I mean, that is the whole idea. I mean, we have not worked with the different people yet, but the idea is that everything we cannot do. Even though NSF says $20 million, if you know these days $20 million with 100 people, everybody gets very small amount of money. We cannot really provide the solution for the world, but we like to work together with others. Okay, so that's what the goal is, like make all the softwares available as they are coming. Even that is one of the objectives. Not wait for year 5 and then give it up. As we are coming, every 3 months you are seeing updated and new releases. So if you or any community would like to work with us, we'll be very happy to work together.
Larry, that way.
Thanks, DK. I was wondering, so the pipeline you showed is fairly linear. Are there any opportunities for feedback loops in that pipeline? And if so, how might you accommodate them?
Yes. That is a very good question. We have that. I didn't go into very advanced. We have another team. I just purely focused on the agriculture, but many times what happens, let's say the drone, you are taking the image, okay? You might have collected a lot of images, but you are not making any sense out of it, okay? So we have another group, we call it like a resource management and scheduling group. So we are developing, think of like we have actually reference architecture group, which is trying to put all these components. And then we have we call it like a resource backplane. There is a management backplane. Okay. Just like a HPC systems you design, the same ideas we are taking here. Okay. And with some fault tolerance. Okay. So if we see that that inference is not happening correctly, or the data rate has dropped, or the quality has dropped, it will get re-triggered. We have all those things. Yeah. I went with a very simplistic version 0. Okay.
I want to add a question, and it's a more general one. So in the audience, we have Mike, who is a farming consultant, not a data scientist. We have Ben, who is from AgResearch, which is one of the largest national labs, to call it in that way. So we have Don, who has a master in agriculture, but not necessarily an HPC expert. And then you welcome all of us to join and participate, which sounds fantastic, and we took your word on that, but I'm concerned about the management of resources. And the biggest challenge, I mean, in the farming world, once someone told me that we don't want drillers, we want holes. And in between, someone will, let's say that I have a problem, and we work with Mike and with Ben, and we want to do something, and we send an email. Mm-hmm. And that gets someone somewhere. And that interaction comes and goes, comes and goes. I'm not assuming that is bureaucracy. I'm just saying, as a white-hair manager, these things just escalate and devaluate the enthusiasm.
Yeah.
You are managing a monumental project. How do you manage the increasing collaboration?
Yes, yes. No, that is a very nice. Thanks for. Let me explain. So in some of the slides, as I said, like some of these collaborations, what is happening. So what we do is, like just like as you said, like if some of you are interested, we can have just a very rough discussion, just to see where interest lies. So then there is we have actually a process in place. So that means we can have follow-up discussion, Zooms and all these things to see what are your requirements are, what we can provide. Then after that, we actually go through a formal MOU kind of things. And then in that MOU, we define a time frame. Okay, not like 10 years, that is not practical, like saying 6 months, 9 months, what we'll do. And then we provide a contact from ICICLE team, and we provide a contact from your side. Okay, so to make sure that these MOU, what we have made, we are actually making progress. And then, of course, within ICICLE, because it is a large organization, we have an executive team, there is a leadership team, and there is actually a full-time managing director, actually. Okay, not me. There is a full-time managing director. She actually takes care of all these things. So we have NSF actually, Tefik can comment on this. These institutes, they have something called a SIP, Strategic Implementation Plan. ICICLE has like almost 170 pages of document of that. We exactly outline in months, years, what we'll be doing. It is a live document, so every year we modify those kind of things. So even these MOUs and all, also we bring it there. And in the end of the year, when we do have these annual reviews, and some of you have participated, we have indicated like how much progress we are doing. So there is a formal process in place.
And I assume as a joint project, it will be a co-funding. Or should we expect from the new government a full funding overseas?
Yes, if you have much more funding from your side, that will always be helpful. We try to allocate some resources, but we cannot totally do it. So if it is a co-funding, or in fact, we can write together also joint funding. Okay, so that's how recently we did with UK. There were some UK calls, center calls. So both the teams put together a proposal to UK. So we can explore all these different options. So we are just providing the basic framework here.
And that's the idea of bringing Professor Panda here. So in order to open the conversation, not to solve things straight away today. If there is no other question, I ask you to join me to saying thank you for the keynote.
Thank you.